Welcome to our exploration of sound. Sound is all around us, shaping the way we experience the world. From the music we enjoy to the conversations we have, sound plays a crucial role in our daily lives. But what exactly is sound, and how does it travel from one place to another? In this video, we'll dive into the fascinating science behind sound, uncovering how it's produced, how it moves, and how we perceive it. Let's begin our journey by understanding the very basics of what sound is and how it comes to be. Sound is a form of energy that we can hear. It is produced when an object vibrates, causing the surrounding air particles to move. These vibrations travel through the air, water, or even solids, reaching our ears and allowing us to perceive sound. For example, when you pluck a guitar string, it vibrates, pushing and pulling the air around it. These movements create waves that travel to your ears, and your brain interprets them as music or noise. So, sound always starts with a vibration. Let's take a closer look at sound waves. When an object vibrates, it creates a series of compressions and rarefactions in the surrounding medium. These patterns move outward from the source, forming what we call sound waves. Sound waves are mechanical waves, meaning they need a medium like air, water, or solids to travel. Without a medium, such as in space, sound cannot travel. The way these waves move and interact with the environment determines how we hear different sounds. There are two main types of waves, longitudinal and transverse. Sound waves are longitudinal, which means the particles of the medium move back and forth in the same direction as the wave travels. In contrast, transverse waves, like those on a string or water surface, have particles moving perpendicular to the direction of the wave. Understanding this difference helps us see why sound behaves the way it does, especially when compared to other types of waves we encounter. Speed of sound depends on the medium it travels through. In air, sound moves at about 343 meters per second, but it travels even faster in liquids and solids. For example, sound moves quicker in water and even faster in steel. This is because particles in solids are closer together, allowing vibrations to pass more efficiently. Temperature and density also affect the speed of sound, with warmer air allowing sound to travel faster than cold air. Frequency is a key property of sound waves. It refers to the number of vibrations or cycles a wave completes in 1 second. The unit of frequency is the hertz, Hz. Higher frequencies mean more cycles per second, resulting in higher-pitched sounds. For example, a whistle has a higher frequency than a drum. Frequency helps us distinguish between different sounds and is essential in music and communication. Amplitude measures the height of a sound wave, which relates to how loud or soft a sound is. A larger amplitude means the wave carries more energy, resulting in a louder sound. Conversely, a smaller amplitude produces a softer sound. Amplitude is an important factor in audio engineering and music production, as it allows us to control the volume and impact of different sounds. Pitch and loudness are two ways we describe sound. Pitch is determined by the frequency of the sound wave. Higher frequencies create higher pitches, while lower frequencies produce lower pitches. Loudness, on the other hand, is related to amplitude. A sound with greater amplitude is perceived as louder. Both pitch and loudness are essential for music, speech, and everyday listening experiences. The Doppler effect is a fascinating phenomenon that occurs when a sound source moves relative to an observer. If the source approaches you, the sound waves are compressed, making the pitch seem higher. If it moves away, the waves are stretched, and the pitch drops. This effect is commonly experienced when an ambulance passes by, and the siren changes pitch as it moves past you. Microphones are devices that convert sound waves into electrical signals. When you speak into a microphone, the sound waves cause a diaphragm inside the device to vibrate. These vibrations are then transformed into electrical signals, which can be amplified, recorded, or transmitted. Microphones are essential in communication, music recording, and broadcasting, making them a vital part of modern technology. Loudspeakers work on the reverse principle of microphones. They convert electrical signals back into sound waves. When an electrical signal passes through the loudspeaker, it causes a diaphragm to vibrate, pushing and pulling the air to create sound waves. This allows us to hear music, voices, and other sounds from electronic devices. Loudspeakers are found in everything from phones to concert halls. Resonance occurs when an object vibrates at its natural frequency due to an external force. This can amplify the sound dramatically. For example, when you sing a note that matches the natural frequency of a glass, the glass may start to vibrate and even shatter. Resonance is important in musical instruments and engineering, as it can enhance or sometimes damage structures. Ultrasound refers to sound waves with frequencies higher than what humans can hear. These waves have many practical uses. In medicine, ultrasound is used for imaging internal organs and monitoring pregnancies. It's also used in cleaning delicate objects, detecting flaws in materials, and even in navigation for animals like bats and dolphins. Ultrasound technology continues to advance, offering new possibilities in science and industry. When sound waves hit a surface, they can bounce back, a process known as reflection. This is why you can hear an echo when you shout in a canyon or a large empty room. The angle at which sound hits a surface affects how it reflects. Understanding sound reflection is important in designing auditoriums, theaters, and even in sonar technology. Echoes occur when reflected sound waves reach your ears after a delay, making you hear the same sound again. Reverberation, on the other hand, is the persistence of sound due to multiple reflections, creating a prolonged effect. Both phenomena are important in music and architecture, as they affect how we perceive sound in different spaces. Not all sound is reflected. Some is absorbed by materials. Soft materials like curtains, carpets, and foam absorb sound waves, reducing echoes and noise. This is why recording studios and theaters use special materials to control sound quality. Sound absorption is essential for creating comfortable and acoustically balanced environments. Quality or timbre of sound is influenced by several factors, including frequency, amplitude, and the nature of the sound source. The shape and material of musical instruments, for example, give each one its unique sound. Environmental factors like temperature and humidity also play a role. Understanding these factors helps musicians and engineers create better sound experiences. Musical instruments produce sound through vibrations. Strings, air columns, or membranes are set into motion, creating sound waves. The design and material of the instrument shape the sound, giving each instrument its own character. From guitars to drums to flutes, every instrument uses the principles of vibration and resonance to create music. Our ears are remarkable organs that allow us to hear sound. Sound waves enter the ear canal, causing the eardrum to vibrate. These vibrations are passed through tiny bones and converted into electrical signals by the inner ear. The brain then interprets these signals as sound. The ear's structure is finely tuned to detect a wide range of frequencies and volumes. Noise pollution is unwanted or harmful sound that disrupts our environment. It can come from traffic, factories, construction, or loud music. Prolonged exposure to noise pollution can lead to health problems like stress, hearing loss, and sleep disturbances. Managing noise pollution is important for maintaining a healthy and peaceful environment. There are several ways to control noise pollution. Using sound barriers, planting trees, and designing quieter machines can help reduce noise levels. Urban planning and regulations also play a role in managing noise. On a personal level, using earplugs or soundproofing rooms can protect us from excessive noise. These methods help create a more comfortable and healthy environment. Sound is a part of our everyday lives. From the alarm clock that wakes us up to the music we listen to and the conversations we have, sound is always present. Even the simple act of clapping your hands creates sound waves that travel through the air. Recognizing these everyday examples helps us appreciate the importance of sound in our routines. Sound is essential for communication. Whether it's spoken language, music, or signals, sound helps us share information and express emotions. Telephones, radios, and public address systems all rely on the transmission and reception of sound waves. Understanding how sound works allows us to improve communication technologies and connect with others more effectively. Modern technology uses sound in many ways. From voice assistants to noise-canceling headphones, advancements in sound technology make our lives easier and more enjoyable. Engineers and scientists continue to develop new ways to capture, process, and reproduce sound, opening up exciting possibilities for the future. Nature is full of fascinating sounds. Birds singing, thunder rumbling, and waves crashing are all examples of natural sound. Animals use sound to communicate, find food, and warn of danger. Studying natural sounds helps scientists learn more about animal behavior and environmental changes. Music is one of the most beautiful uses of sound. Musicians use different frequencies, amplitudes, and rhythms to create melodies and harmonies. The science of sound helps us understand how instruments work and how we perceive music. Whether you play an instrument or just enjoy listening, music is a wonderful example of sound in action. Acoustics is the science of how sound behaves in different spaces. Architects and engineers use acoustics to design buildings like concert halls and theaters, ensuring that sound is clear and pleasant. Good acoustics can make a big difference in how we experience music, speeches, and performances. Sound can affect our health in many ways. Pleasant sounds can relax us, while loud or harsh noises can cause stress or hearing damage. Doctors use sound waves in treatments and diagnostics, such as ultrasound scans. Being aware of the impact of sound on our health helps us make better choices in our environments. The future of sound technology is full of exciting possibilities. From advanced hearing aids to immersive virtual reality experiences, new innovations are changing the way we use and understand sound. Researchers are exploring ways to make sound technology more efficient, accessible, and enjoyable for everyone. In this video, we've explored the science of sound, from its basic properties to its many applications in our lives. We've seen how sound waves travel, how we hear them, and how technology uses sound in creative ways. Understanding sound helps us appreciate the world around us and inspires new innovations for the future. Thanks for joining us on this journey through the world of sound.